I'm looking to design a formula to imagine the angle of deflection for a light passing through a prism, and basically this light ray is going to turn twice. Once when it gets into the prism, it's going to turn this way. I think of it as a car hitting the mud, so the front tire slows down first and then causing the ray to turn to the right. And then out here, the left tire hits the highway first, so it causes the ray to turn right once again. So I'm going to redraw this diagram with just this line drawn in there, and then I'm going to use the theory that we have. We want to use Snell's law, which says n1 sine theta 1 equals n2 sine theta 2, except we're going to use it a couple different times. The first time I'm going to have a perpendicular right there, so this will be theta 1, this will be theta 2, and the second time I'm going to have the perpendicular line right in there, and so we want the angle from the ray to from the perpendicular to the ray on that side, and then from the perpendicular to the ray on that side. That's theta 3 and theta 4. And I'm going to call this the index of refraction inside the prism as n, and that outside I'm just going to say it is 1, because this is going to be air. I'll make it kind of a stylized one, so that if you decide to put it in water or some other liquid, so we'll still have that information in the equation. But then on this angle here, we'll figure out theta 2, because it'll be 1 times sine theta 1 equals n times sine theta 2, and then on this part of the thing we'll have n times sine theta 3 equals 1 times sine theta 4. Now I need to find the relationship between theta 2 and theta 3, and to do that I'm going to say that this angle here, let me see if I can draw that a little tighter. Okay, so this right here would be a right angle. So this angle here, draw it in a different color. This angle here would be 90, basically 90 minus theta 2. And this angle here would be, let's see, what color should I draw that? Red again. This angle here is a 90-degree angle. So this angle here would be 90 minus theta 1. And this angle here is going to be an angle of, well, we don't know. No, yeah, we do, because this is, a prism is an equilateral triangle, so these are all 60 degrees. So all the external angles of the prism are 60 degrees. So we can add together this angle plus this angle plus this angle, and the sum of the measures of the internal angles of a triangle are 180 degrees. So we'll have 90 minus theta 1 plus, wait, no, I mislabeled these up here. This was 90 minus theta 2, this should be 90 minus theta 3, and so we're going to add up these angles, 90 minus theta 2 plus 90 minus theta 3 plus 60, 90 minus theta 2 plus 90 minus theta 3 plus 60, that should give us 180 degrees. So that makes this thing be 180 minus theta 2 minus theta 3 equals 180. I can cancel the 180 and 180. Wait, I left out the plus 60. Plus 60 equals 180. And that becomes, let me add theta 2 plus theta 3 to both sides. 60 equals theta 2 plus theta 3. So we could say that theta 3 is going to equal 60 minus theta 2. So I've got a relationship between theta 1 and theta 2, and a relationship between theta 2 and theta 3 right down here, and then I've got a relationship between theta 3 and theta 4. And what I want is to have theta 4 as a function of theta 1. So if I solve this for theta 4, I'll have theta 4 equals inverse sine, or arc sine, call it inverse sine of, it'll be n sine theta 3. And I'll go ahead and put in a n over 1 there for generality. Whoops, this should be theta subscript 3. And in turn, I will replace the theta 3 with 60 minus theta 2. And then I'm going to use this formula and solve that for theta 2. So let's bring that down where I can see it. And theta 2 is going to be inverse sine of 1 over n times sine theta 1. And I'm going to plug that into there. So copying this down and plugging in right here, sine inverse of 1 over n sine theta 1. Wow, great. So that looks like a very uncomplicated formula, right? Let me make a massive assumption and simplification to this formula. We're going to assume a small angle. And let me justify this for a moment. When you use the small angle formula, what you're doing is assuming that you've got an angle that is small, which means this is the, well, right here is, if you measure this angle in radians, the arc length of this thing is r theta. If this is r. Also, this distance here is r. Let's see, this is r sine theta, and this distance here is r tangent theta. You can see that a little better if I label both this length here. This length here is r, and this length here is also r. Notice that it doesn't include this little bit at the end. But the idea behind the small angle formula is kind of to use the fact that when this angle is small, this length here, and this length here, and this length here are all pretty close to the same length. So we can always claim that sine theta, or with the small angle, sine theta is approximately equal to tangent theta. But if you also put your units in radians, you can also claim that that is approximately equal to theta, which is that arc length there. So what I'm going to do is convert this angle measurement to radians. So 60 degrees is 60 degrees is 1/6 of the unit, 1/6 of the way around the unit circle, right? 1, 2, 3, 4, 5. I drew that really badly, but it is 1/6 of, and how far is it all the way around the circle? It's 2 pi radians all around the circle, and 1/6 of that would be 2 pi over 6, or pi over 3. So I'm going to change this formula up here, convert it from degrees to radians, which just means that I change this constant here from 60 degrees to pi over 3. Wait, I can erase it. To pi over 3 radians. And now that it's converted to radians, I can change this sine theta 1 to just theta 1 over n. I can change that inverse sine to just 1 times that. And let me go ahead and put that 1 in there. I can change this pi over 3 stays pi over 3 minus this sine just becomes a unit function. We'll have n over 1 and get rid of that sign there. And wow, that is a great simplification, isn't it? We basically just removed all of the sine terms and treated it as a function that means times 1. So we can multiply through by n. We'll have n pi over 3 minus theta 1. And furthermore, using that small angle formula, you will have, if you got a light ray that's split into 2 beams because let's see, theta 4 is going to be this. So if you have we'll basically just make this a function of the angle coming in and the n of the substance, and you get n pi over 3 minus theta 1. And if you want to know how 2 beams split, then you'll go theta 4 with n equals, say, 1.54 minus theta 4 of where n equals 1.50. Subtract those two, and you'll get something independent of theta 1 because it will cancel out. So you'll just have n pi 1.54 times pi over 3 minus 1.50 times pi over 3, and that will give you the angle in radians. And then you convert it to degrees by taking your answer in radians times divide by pi radians and multiply by 180 degrees, and you'll get your answer in degrees.